Assalamualaikum warahmatullahi ta'ala wabarakatuh, and welcome to MCTE 2311 Signal and System Analysis. In this video, I will talk about classification of signals. So basically, for our course, these are the type of signals or the classification of signals that we will look into. However, for this video, I will only talk about these first four types of signals. So the first one is a continuous and a discrete signal. For continuous signal, it refers to a signal that has a value at every instant of time over some time interval. For example, if you look at the graph here, okay, you can see that you have amplitude value at every second of time. Okay, you have amplitude at 0 second, which is 0. You have amplitude of approximately 1 at 0.2, and in between 0 and 0.2 also you have continuous value of amplitude. And continuous time is always expressed with respect of time. Okay? For example, as shown in this equation, okay, the signal x is represented with respect to time t, x of t. Some example of continuous signals are sine waves, cosine waves, and triangular waves. For a discrete signal, it refers to a signal that has value only at specific points in time and not in between. Okay? For example, if you look at the graph here, okay, you can see that there are small circles here. Okay, so you have amplitude, okay, at these respected small circles. However, you don't have amplitude in between these two values. And discrete signal is always expressed with respect to sample, which is n. Okay, for example, like you can see in this equation, x of n. Example of a discrete signal is a stock price. Next one is analog and digital signal. Okay. So analog signal refers to a signal whose amplitude can take an infinite number of values in a continuous range. Okay, for example, if you look at the graph here, okay, the amplitude, okay, changes continuously, okay, with respect to time, okay, within this time period. Okay, so you have infinite numbers of amplitude that it can take. Okay. However, for a digital signal, it refers to a signal whose amplitude can take only finite number of values in a continuous range. For example, okay, a binary signal only takes two values of amplitude. For example, 0 and 1, or sometimes -1 and 1. Okay, so if you look at the signals here, okay, within this time frame, okay, the amplitude changes between 0 to 1 only. Okay, and people sometimes consider analog signal as continuous signal, while digital signal as discrete signal. However, this is actually not the case. They are actually different. Okay, so to describe the difference between these four signals, I show you these four graphs. Okay, so for the first one here, you can see that the amplitude, okay, changes continuously with respect to this time frame. Okay, so this first graph refers to a signal that is continuous and analog. Okay, for this graph here, the second one, you can see that the amplitude okay, is available at every time instant, okay, within this time frame. However, the value of amplitude changes only between two values. Okay, let's say maybe minus 2, 2 and minus 2. Okay, so this graph here refers to a signal that is continuous and digital. Okay, now this graph here, okay, you can see that it takes an infinite value of amplitude, okay, because it changes continuously within this time frame. However, the amplitude is occur, okay, or only available at a certain time sample, okay. For example, only at this denoted by this small black circle. Okay, so in between these two black circles, there are no amplitude, okay, or value available. So this graph here refers to a signal that is discrete and analog. Now this last one, okay, you can see that within this time frame, it takes only two amplitude, okay, changes between only two amplitude, let's say maybe 5 and minus 5, and at the same time it occurs only at a certain time interval, okay, as denoted by these small black circles. So this graph here refers to a signal that is discrete and digital. Okay, so I hope this example show you clearly the difference between continuous, analog, digital, and discrete signals. The next one we look at periodic and aperiodic signal. Periodic signal refers to a signal where it repeats itself over a certain time frame. Okay, for example, if you look at the graph here, you can clearly see that there is a pattern, okay, of this signal over a certain time period. Okay, you can see that it repeats itself after a certain time. Okay, so when we study periodic signal, there are a few important terms that we have to know. The first one is called a cycle, okay, which is refers to the completion of a full pattern. Okay, so if you look at the graph here, if you start from this point, you go up like that and go down back. So this one is a full cycle. Okay. The next one is period, which is refer to the time required to complete one full cycle. Okay, so in this graph here, this TO or the T node here is the period. Okay, and a periodic signal, okay, must satisfy this equation, okay, in terms of a continuous time signal, and this equation in terms of a discrete time signal. So some examples of periodic signal is sinusoidal signals. Okay, so sinusoidal signals here refers to a sine wave and a cosine wave. Next one is aperiodic signal. Okay, it refers to a signal that has no certain pattern. Okay, for example, if you look at the graph here, okay, it goes like that, and you cannot see the a certain pattern, okay, over this time range. Some example of aperiodic signal are noise, exponentially growing or exponentially decaying signals. Okay, so we look into detail on periodic signal. Okay, so in the previous slide, we say that a periodic signal must satisfy this condition. Okay, xt equals to x, t plus minus n t naught. So this n here refers to integer, and this t naught here refers to the time period. Okay, so this equation simply means, okay, you will get the same signal, okay, the same repetition of signal if you move the signal forward one period, or if you move it backward one period. Okay, so T naught here refers to fundamental period, which is in second. Okay, and the fundamental period is actually the smallest positive value of time for which the signal is repeating itself. Okay, so if you look at the graph here, okay, if you go from here, okay, you follow the signal until here, you can see that after this time, it will repeat itself. Okay, so this time is the fundamental period. Another example here. So if you look at this signal, okay, let's say if you take it from here, go up and down. Okay, so the time period for this periodic signal is 2 seconds. Okay, 1 second, 2 seconds. Now this one, okay, exponentially decaying signal. Okay, if you go, let's say if you take it from here, you go up and down. Okay, so from here it repeats itself. So this signal has a time period of 1 second. Now another important parameter that we have to know when we talk about periodic signal is fundamental cyclic frequency, okay, which is simply the reciprocal of fundamental period. Okay, so the signal is hertz. The second one is fundamental radian frequency, okay, which is given by this equation, and the unit is radian. Okay, now we look at random and deterministic signal. Random signal refers to a signal that cannot be described by any mathematical function. Okay, sometimes it is also called probabilistic signal, and its value cannot be predicted exactly within that time frame. Example is noise. Okay, so if you look at the signal here, okay, this is noise. Okay, the graph of noise. So it has a very high frequency like this. Okay, so it cannot be represented by mathematical function. Next is a non-random signal. Okay, it refers to a signal that can be represented mathematically, for example like this, okay, which is a cosine wave. Okay, also called a deterministic signal, and its value can be determined, okay, at a certain time over the time frame. For example, is sinusoidal signal. Okay, so if you look here, this signal, okay, you can represent this with a mathematical equation. Now this is a problem example. Okay, so the question asks you to determine the fundamental period and fundamental cyclic frequency, okay, T naught and F naught, for these three signals. Okay, so you go ahead and try this, and I will give the solution in the next video. So I see you in the next video. Thank you.